Hello, we got a video on day 2 of solving equations. A lot of this is refresher, but we're stepping up the level of the content here. Very similar to other videos I've done with you. I'd like you to do a little bit of a warm up. So if you'll pause your screen and work out those 5 warm up problems just as a refresher from our previous content. If you watched our previous video in this series, you should be on ready to do these. So just pause the screen, do those 5, come back and check your answers. Okay, I think everybody's had a chance to do that. Here's my answers. Make sure you got what I got. If not, this is something you want to talk to me about or talk to your teacher about, and make sure that you didn't make any small errors. Go back and retrace your steps. All right, doing a couple more examples with you. We're going to bring in some variables on both sides of the equation and just kind of step up the challenge today. Got a couple of examples, and then we're going to get into some word problems. All right, so here we go. Variables on both sides of the equation. Okay, so what I personally like to do, and this is not at all required, but what I like to do is I like to send the variables to the side that has the most variables. And the reason I like to do that is because I can keep my coefficient, that's the number in front of the variable, I can keep my coefficient positive, and keeping that positive actually saves me a step. So I'm going to do that, but keep in mind that you don't have to do that. If you like to have your variables always on the left side, feel free to keep doing that. Just make sure you don't forget about a negative symbol there at the end or something. All right, so I'm going to just go ahead and work this how I would do it. I'm going to deal with the variables first. So I'm going to get the variables with the variables and the numbers with the numbers. So 9x is bigger than negative 3x. So I'm going to send all the variables to the right, which means all the constants or the numbers go to the left. All right, here we go. So the opposite of negative 3x is plus 3x. So, oops, let's try that again. We're going to add 3x to both sides. And when I simplify, negative 3x and 3x is 0, so those are gone. 30 is equal to 12x minus 6. Now I need to, again, get the constants with the constants and away from the variables. So I'm going to add 6 to both sides, as that's the inverse operation of subtracting 6. 36 is equal to 12x. Negative 6 plus 6 was 0, so those canceled. Now, finally, to get x by itself, 12x means 12 times x. So the inverse operations is divide by 12. Divide both sides by 12. 36 divided by 12 is 3. Now, a lot of times we don't love to leave our answer with the variable on the right, but know that the symmetric property of equality allows you just to switch the order. 3 is equal to x, so x is equal to 3. And there is our solution solved. So reverse order of operations just like before, but making sure we get the variables with the variables and the constants with the constants. Okay, step it up a little bit further. I want you to try this one out. Feel free to pause your screen and do this on your own and then come back and watch me do it. Or if you just need to follow along with me, that's fine too. I am going to go ahead and distribute ahead of time. You don't have to do it like that, but I would recommend, because then we don't lose any of the symbols. Keep it in mind when we distribute, we're multiplying everything in the parentheses by the coefficient. So that's going to give me negative 8 plus, because a negative 2 times a negative 1x is positive 2x equals 6x. 6 times x is 6x, and 6 times 2 is 12, and then have my plus 3x. Notice that I don't have these parentheses any longer, because once I distribute, I no longer need them. So no longer do I have the parentheses. Now I'm looking to simplify and combine like terms. Are there any like terms on the left? No. Negative 8 doesn't have an x. 2x has one. They're not like terms. But over here on my right, I do have some like terms. 6x and 3x are like terms. So I can add those two things together. So my next step is going to be the simplifying by combining like terms. Left the left side the same because there were no like terms, but 6x and 3x makes 9x plus 12. Again, I didn't add everything together because 12 doesn't have an x. They're not like terms. Now, there's 2x's on the left, 9x on the right. There's more x's on the right side, so I'm going to send every variable to the right, which then means I'm going to have to subtract 2x because I'm doing the inverse operation of plus 2x. Those add up to 0, so it's no longer affecting my problem. 9x minus 2x is 7x. Bring down my 12, nothing to add to it. Now I need to keep the x's by themselves, so I'm going to subtract 12 from both sides in order to isolate the variable. Negative 8 minus 12, keep in mind, with your integers, that's negative 20 equals 7x. Now at this point, you might be a little bit nervous because that's going to make a decimal. And it's okay. Decimal answers don't mean that you're wrong, but we just want to double check sometimes when we get those answers that look a little bit weird that we go back and look at our work. So I'm just kind of checking back my work right now. But to get rid of 7 times x, I'm going to divide by 7. So negative 20 divided by 7 and 7 divided by 7. 7 divided by 7 is 1. 1 times x is just x. That's why I'm able to cancel those out. Negative 20 over 7 is really not going to reduce it all for me, so that's actually a simplified fraction. If you are allowed to do decimals, go ahead and do decimals there. Make sure you round to whatever place they ask you to round to. All right. Now we are going to try out some word problems.